Today we're going to look at graphs of logarithms, and we are going to basically focus on what does the minus h in this equation do, and what does the plus k do. And honestly, we've graphed enough functions at this point that you probably can already guess. This minus h is either going to move it left, right, or up or down. What's your guess? Left or right. And the plus k is probably going to move the graph up or down. So let's take a look. Number one is a parent function. So if you want to write parent function next to this one, log base 2 of x. Now, if you turn your paper on its side, if you rotate your paper 90 degrees, I can't do that with my screen because it'll actually like rotate on here and we don't want that. But if you turn your paper 90 degrees, this graph looks like exponential growth or exponential decay. Logarithms are the inverse of exponential growth and decay. So they took the exponential growth function and flipped it over a diagonal line, and that is the log graph. Exponential graphs, exponential growth and decay, have a horizontal asymptote. Notice this one has a vertical asymptote. So right here on the left, the graph gets really, really close to touching the y-axis, but doesn't touch it and doesn't cross it. Over on the right side, this is going to continue increasing. It'll increase slowly, but it will continue increasing. There's no asymptote on the right side. There's only an asymptote on the left side, and it's a vertical asymptote. What is the equation for vertical lines? Vux?
Y equals
X equals. And if it's right on the y-axis, your x value is 0. So the parent function of a log graph has an asymptote of x equals 0. Because there is a vertical asymptote, there's x values here. Here's an x value of 1. Here's an x value of 2. Here's an x value of 4. Are there any x values to the left side of that asymptote? So all of our x values are bigger than 0. Your domain is x is greater than 0. Your asymptote and your domain are linked together. Do you see how this is reverse from the last graphs that we did? Previously, we had a horizontal asymptote, so the asymptote was linked to the range. Now we have a vertical asymptote, so the asymptote is linked to the domain. Yeah. And then your range, in our last unit, the domain was all real numbers and the range was tied to the asymptote. This time, the domain is tied to the asymptote, so the range is all real numbers. And for every single log graph, your range is going to be all real numbers. So at this point, you could go through this entire page and write all real numbers next to every single range on this entire page. Okay, we guessed that the minus h would move the graph left or right. So take a look at this one. It says plus 2 inside the parentheses. Take a look at what happens on the graph. Notice here's your new asymptote. Instead of being on the y-axis, that asymptote has moved right 2. So next to this graph, you might want to write down right 2. Sorry, left 2. Because apparently I can't tell directions this morning. You know,
Nope.
It's a Tuesday morning.
No excuses.
I know, no excuses. Our asymptote, because we moved left 2, is x equals negative 2. All of your points are on the right side of the asymptote, so the domain is x is greater than negative 2. What's the range? All real numbers. And again, notice that your asymptote and your domain are linked together. I want you to look at number 3 and decide your asymptote, domain, and range. you can also look up here to help you figure out what your asymptote is. The -2 in the parentheses is going to move the graph actually right 2 this time, which puts your asymptote at x equals +2. Our domain is x is greater than +2, and our range is all real numbers. This is a piece of cake. Basically, this is all of our notes today. All right, let's look at 5, 6, and 7. Number 5 is another parent function. This time it's log base 3 of x. But again, our asymptote is at 0, so x equals 0. Our domain is x is greater than 0, and our range is all real numbers. Okay. We guessed that numbers outside of the parentheses would move the graph up and down. And take a look closely at this picture. I'm going to focus on this point right here, the point 1, 0. That point is now here at 1, -2. That point used to be here, so the point moved down 2. This -2 represents down 2. But if our asymptote is vertical, moving up and down isn't going to shift where the asymptote is. So notice your asymptote is still right here on the y-axis. Our asymptote is still x equals 0. Our domain is still x is greater than 0. And our range always is all real numbers. Here's that point in number 7. The point originally in the parent function was there on the x-axis. In this example, it moved up 2. So this +2 is moving the graph up 2. Anyone want to be super brave and guess the asymptote? X equals 0. Domain? Okay, range? All real numbers. Up and down does not affect the asymptote, only side to side. If you've got a vertical asymptote, side to side movement is going to shift that asymptote along with the graph. Up and down, you can move a vertical line up and down, it's still the same vertical line. Number 9, this is actually the same parent function that we saw in number 1. So again, x equals 0, x is greater than 0, and all real numbers. No. The parentheses around the x just show you that only x is inside the log. So parentheses are like C and C, the parentheses aren't there. We could definitely put the parentheses in. What do you see different in part B? There's a negative inside the log. This negative inside the log is a horizontal flip. And notice, instead of the graph going up from the asymptote and to the right, now the graph is going up from the asymptote and to the left. A horizontal flip is going to affect either the domain or the range. Our asymptote is still at 0, but now this point has an x value of -1, -2, -4, and so on. Our domain is going to be x is less than 0. So if there's a negative inside and it flips that graph over the asymptote, that's going to flip that domain, flip the sign in the domain. What's the range? All real numbers. In C, the only difference is a negative in front. That is a vertical flip. So notice, instead of starting down and going up and to the right, this starts up and goes down to the right. Oopsie. Oh, come on, flip back. There we go. This vertical flip doesn't affect the asymptote, and honestly, it doesn't affect the domain and doesn't affect your range. Your asymptote is still x equals 0. The points are still on the right side of that asymptote, so your domain is x is greater than 0, and your range is all real numbers. If I gave you a page full of log graphs, do you feel like you could pick out the asymptote, domain, and range for all of them?
Oh, yeah.
Okay. On the next page, we're going to practice entering these into our calculator. Tomorrow, we are going to graph them and put the points on a graph. Today, we're just going to look at what happens and kind of practice putting it in the graph. So take a look at number 10. This is the log equation that we're going to enter. What do you think this plus 4 is going to do to the graph? Left 4. I think that is correct. What do you think the plus 2 is going to do? Up 2. On your assignment, it's going to give you an equation and ask you, what's the horizontal movement? On this one, you'd say left 4. It's going to ask you, what's the vertical movement? You would say up 2. You can get that without graphing this. Then it will ask you for the asymptote, the domain, and the range. Which one do we know is always going to be the same no matter what? Range, all real numbers. Could we find the asymptote and the domain right now without putting this into our graph?
Sure we can.
If the graph moved left 4, what's the asymptote going to be? X equals -4. I don't see any negatives, so I think the domain is going to be x is greater than, but this is where plugging it into the graph might help you. Let's learn how to put logs into the graph. So grab a graphing calculator. If you have a newer graphing calculator, you'll have this feature. If you don't have a newer graphing calculator, I might have to teach you the workaround. Go into the y equals button where we enter equations to graph. And our equation starts with 2 times the log base 3. So I'm going to type in the 2. We do not want to use the log button. The log button is base 10. This one is not base 10. It says that it's base 3. To find log base 3 in your calculator, follow these steps in the box. Press alpha and then window. So alpha button, that's the green one. Window is the button just to the right of y equals. And on the newer calculators, it pulls up this little window. Mine might have a few more features than yours has, depending on how new your calculator is. The one that we want is number 5, log base. So you type in number 5, and it gives you this fancy little spot to put your base and parentheses for you to put stuff inside the log. So now you can type in that base of 3, and you can type in x plus 4, and you can type in the plus 2. Oh, no. Before you type in the plus 2, you need to get outside of the parentheses and then enter the plus 2. So when you push graph, you get this picture. And the asymptote is kind of weird. These graphs, as you approach a vertical asymptote, these graphs kind of freak out. So it doesn't look like it continues, but it actually does continue getting closer and closer and closer to that asymptote without touching it and without crossing it. So from this picture, you can definitely see that the asymptote is x equals -4. All of the points are to the right of that asymptote, so our domain is x is greater than -4. If you have an older calculator, this is how you would have to type it in. If you have an older calculator that doesn't have the alpha window feature, just come see me sometime with your calculator and I will help you learn your calculator. I would like you to try number 11 on your own. So